So what is the universe up to is the subject of the talk. We know the universe is a very, very beautiful, beautiful place, and we know that lots of people have thought about the universe in lots of different ways for a very long time, with big debates raging at the moment still. I want to really begin this talk. This talk features lots of different people, apart from anything else, apart from my own journey really in various material over the last few years. Involves Jean-Michel throughout it in different ways. So I want to start my talk with the Wombles. When I was small, we used to go and have tea with a lady called Elizabeth Beresford, who wrote the Wombles, and she based the Wombles on. Did you know that the WOM of Wombles is actually wise old man? And she was part of an esoteric group that thought they could change the world using television, and respected all sorts of different sorts of ideas. And the Wombles were based on this idea that you could get children to become more environmentally friendly by having little animals that showed you that. There's Elizabeth with Great Uncle Bulgaria. Up the road, where my grandparents lived, my grandfather was a very interesting fellow as well. And he had been the Beatles meditation teacher running the Maharishi thing back in the 1960s, and was a man of many talents, was also running the finance director of the post office. And here is at the post office entertaining his secretary with a machine he'd built called a harmonograph. The harmonograph draws pictures of musical intervals very beautifully, and I grew up playing on one of these machines. Here's the one that he built for me in his garage. I was very pleased with this photograph actually when I took it age 7, because it was the first picture I took that actually had movement in it. Look at the weight at the bottom. You can actually see it's blurred. I was very struck by this fact. Basically, you have a couple of pendulums and a felt tip pen and a table, and you get to see music, really, or see musical intervals. Later on, I worked on a book on the subject with him in our series. He was called Anthony Ashton. Here are some more of the shapes that the harmonograph drew. One of the things my grandfather taught me was that if you wanted to make a shape, let's say that threefold one at the bottom, then all you needed was a pendulum in the ratio 2:1 going opposite directions, in which case the ratios add, so 2:1 gives you 3. Or if the pendulum's going the same way, two circles going the same way, it's the difference between the ratio. So for instance, 2:5 would give you a 3-fold design if the pendulums are going the same way. This was becoming quite useful later on. My grandfather used to talk to me about all sorts of interesting things. We'd go on long walks together. One of the things that very much interesting was convergent evolution. Convergent evolution is quite interesting, really. It's fascinating. It's gaining ground all the time at the moment. It suggests a Platonic aspect to evolution. Convergent evolution has noticed, for instance, that if you take the marsupials and the placental mammals, here's the marsupials on the right and the placentals on the left, sorry, other way around, marsupials there and the placentals here. Let's look at the mouse, for instance. There's no relationship between this mouse and that mouse, in the sense that one hasn't evolved from the other. All mammals evolved from something that looked a little bit like a sort of, little tiny little thing. All of these things have come from a single base genetically, and yet they've evolved very similar outward forms to fill their respective niches in the environmental system. So you've ended up with cats, you've ended up with anteaters with their noses, you've ended up with mice, you've ended up with flying squirrels, flying phalanges. None of these have any genetic relationship to one another within their own species. It's not like a cat's come from another cat. They've actually formed their own outer morphology. Another good example is sharks. In Lake Tanganyika, there are sharks that look like sharks, but actually have evolved from quite small little things that bear no resemblance to any shark. So they've got to being shark-shaped by a completely different route to sharks in the oceans, and are not genetically related at all. So again, you've got the same outward morphology that's resulted from a different evolutionary journey. The camera eye is another example. It's independently evolved 18 or 19 different times. The chap who's doing all the work on this is really the expert. It's a man called Simon Conway Morris at Cambridge University, and he's great on it. His book's called Life Solutions, and it's his great book on the subject. And he thinks that it's really that life, anywhere in the universe could well look quite similar. There'll probably be sharks. If there is life on Europa under the ice, it'll probably have shark-shaped things in it, because it's the best design, and evolution finds the best design again and again. So my grandfather and I used to talk about things like this as we were walking on the Welsh borders. And he was a man of very many interests. The thing that interested him most of all, though, was the universe and what it actually was. He was very interested in it. And this is a plate you don't often see these days. It actually shows you the latest plot of the universe, what it actually looks like at a macro scale. I'm just going to stay here. So in the top left-hand corner, we've zoomed out. It really looks just like a bit of granite. We're zooming in all the time. You can see that the universe is actually full of bubbles, and it's a bit bubble-shaped. It's like full of voids. And that the galaxy clusters, which are all you can see here, are actually superclusters. And in this last diagram, apparently I've got a dot on here. Where is it? Timer, volume, dot. There. See that one there? That little dot there. That is a supercluster of probably 20,000 galaxies. That little dot. So you can see just how very big the universe is. It's quite hard to visualize it normally. You don't often get pictures, but these latest plots, which are basically dark matter plots, which are where they think all the stuff is, you can really get a sense of what the universe actually looks like. Of course, inside the galaxy clusters, you've got, inside the superclusters, you have clusters of galaxies, galaxy clusters, and inside each galaxy, there are 100 billion stars. The universe is very, very big indeed, and we really don't have any idea what it is at all. The current model of it as essentially sort of static sort of thing, that's a bunch of material that's just gone bang, is clearly, we're going to see over the course of this talk, very limited and already out of date. My grandfather was very, very interested in this primarily. It's called the anthropic principle, developed in the 1970s by Professors John Barrow and someone else at Cambridge, two professors. And what they noticed was that the universe is extremely, extremely finely balanced for biological life. Very, very strangely balanced. There are four main forces in physics. You've got gravitation, electromagnetism, strong nuclear force, and weak nuclear force. If you fiddle with any of these constants, even slightly, these basic forces, how strong they are, what you get is essentially a universe full of black holes, where everything flies apart too fast. Nothing works. You couldn't possibly get any life in it. That's one of the main anchors of the anthropic principle. How did the universe, in its first moments of expansion, get to be so beautifully balanced like this? And it really is a knife edge of balance, so that complicated structures like galaxies could even form in the first place. And once you've got galaxies, this is a sort of black hole type thing. You wouldn't even get stars if you changed the value of gravity by 1%. Nothing would work. So it's a big problem. The whole universe is essentially finely balanced, a bit like this sort of mobile here. It's a good way of thinking about it. Everything's perfectly balanced from the very instant of the Big Bang. You get other problems like water. It's a big anthropic question with water. It's probably the most perfect solvent designable. You couldn't design a better solvent for things. Without water being the way it is, without the fact that ice floats on it, for instance, again, no life could have formed anywhere in the universe. It's almost impossible to conceive of a better solvent. There are people working on this all the time at the moment. Carbon, another good thing. Carbon's a sort of freak of nature. It shouldn't really be there at all, but because of a particular because of a particular twist in the carbon cycle inside stars, you do get a lot of carbon in the universe, and it behaves in a very strange way. It forms long chain molecules. There are lots of very strange things, but basically the big one is, in the end, this fine-tuning with the forces, that without which we would have no life at all. And we used to think about this a lot. Here's my grandfather taking me camping aged 5. And really, he used to talk all through the night about these sorts of things. And when I was 7, and right the way through to my late 20s when he died. Something else that interested him was plasma. Plasma is 95% of the universe. In fact, almost 97% of the universe, almost the same amount as the missing dark matter. And the interesting thing about plasma is that it forms itself into filaments. And my grandpa was very, very interested in this theory called plasma theory, which held that there was no dark matter, that the entire universe, in fact, was full of plasma, which is basically ionized gas, the fourth state of matter after gas. It's a form of gas that's so highly energized, that the electrons have been stripped off the rest of the atom, off the nuclei, and just sort of flit around. A lot of work on plasmas was sort of showing that they behave in a sort of holistic way. There's a sort of integrated field to a plasma. And there is this model of the universe that the universe is essentially one giant electromagnetic conducting system, really. A little bit like a brain. My grandpa was much taken by all these kind of things and was reading up a lot on it when he died. And I used to think about this a lot. This is a rare picture of me as a hippie. Yeah. And I became interested in another take on the anthropic principle, which is known as the Fermi paradox, Enrico Fermi, after whom Fermilab is named. So if the anthropic principle simply states that the universe is very finely tuned for life and that we fiddle with it at all, then no life is possible. So we got this finely tuned universe, maximized, optimized for life. It really is. But if it's so finely tuned for life, then where are all the aliens? So that's the Fermi paradox. Where are all the aliens? They should be all around us. There should be alien worlds, stuffed full of aliens, and flying around everywhere. And suddenly I realized maybe they were. And I headed down to Wiltshire. That's another rare hippie picture of me. I still hadn't met Jean-Michel at this stage, although I had started reading about his work. But I did do a lot of work on the geometry of crop circles. Here's a crop circle here which took my fancy. It was at Core Hampton. And I noticed that if you drew lines just touching a straight line would just touch those three circles. I became interested in these edge alignments and geometry of crop circles. This one, Upton Scudamore, fascinated me. It's one of the first ones I worked on. Colin Andrews and Pat Delgado did a lot of work on it. And I was relatively carefree, and I spent my summers in the fields, crop watching and hanging out with UFO spotters. But with this one here, I discovered something really, really fascinating that stayed with me for a very long time because it taught me a lesson in the same way that the geometry, Howard Crowhurst was saying that the sites were teaching the geometry, the crop circles were teaching us geometry at that stage. So if you put a triangle around the central circle, it was picking up the outer bits. If you put two squares around the central circle, you can see that defining the geometry. If you put a pentagram on the whole figure, it also synchronizes with the geometry. And this is a very interesting point that the pentagram, the same job is done by a pentagram as an octagram. So where the lines cross on a pentagram, which is a phi relationship, a golden section relationship, defining that inner circle from the size of the whole thing, an 8-pointed star does the same thing. So I was kind of into all this stuff, and that was it. And I was doing lectures in this very room back then. I was quite a young hippie on this, and everyone got very excited. And I wrote a big computer program to take my work further. And one day I fed the solar system into it to see what would happen, to treat the solar system as a crop circle, essentially, see if I could find any geometry. And I strangely discovered this, that Earth and Mercury, the innermost planet, the three inner planets are Mercury, nearest the Sun, and then Venus, and then Earth. So Mercury, the innermost planet, that a pentagram drawn on Earth's orbit, where the arms cross, like in that last crop circle, gives you the mean orbits of Earth and Mercury, and also the mean relative sizes of the two planets, defined by the same geometry. So Earth and Mercury's orbits are in the same relationship as their physical sizes. I thought that was a strange coincidence and began to hatch up the idea for a book of these coincidences and started to do more research. And of course, we know that because the pentagram and the octagram do the same thing, that the 8-pointed star also gives you the size of Mercury and Earth, or the orbits of Mercury and Earth. As we saw from that crop circle, the 8 and the 5 are very similar. This one's a key diagram. We're going to come back to it later. The 8, defining the mean orbit of Mercury. I sent these results off to Jean-Michel, who I'd not met, but I was reading a magazine he was doing called The Seriologist. And he very kindly wrote back and even published in the next issue of The Seriologist my little result on a different crop circle. And I was thrilled. It was the first time I'd ever appeared in print, and the whole thing was terribly exciting, and the great man had written to me. And then he really championed me enormously very shortly afterwards, because I was very cruelly accused of hoaxing all the crop circles by various people who still remain nameless. It was all over the press. I was in the Independent. Everything was all Martineau doing everything. And they were all saying, how can he come up with all this geometry if he must be making them? All this extraordinary geometry, he's got to be the one making them. And just as the thing reached its peak, and I think I was about to be assassinated or something, the sheer hatred of New Agers all over the planet, John came to my rescue. And not really knowing anything about me, we'd still not met, he declared to everyone that a strange coincidence was that my great-uncle had been his housemaster and Greek tutor. And he declared that the Martineaus were untouchable. He said, there's no way a Martineau could ever do anything so rotten as hoax a crop circle, which I thought was really, really a good egg. And so I met him not long afterwards. John's biggest discovery, and the bit for me that was, I can't say biggest discovery because everyone got something different from his work. The thing that impressed me the most deeply was his fundamental result featuring the size of the moon and the size of the Earth, which then filtered through into his metrology. The moon being 3 and the Earth being sized 11 meant that if you brought the moon down to the Earth, it squares the circle. This is a very, very interesting thing. I was really struck by it. It seemed incredibly strange to me that the fundamental heavenly body, the moon, our closest heavenly body, should synchronize in this way with the Earth. So essentially, if you look at the diagram, for those who don't know it, we bring the moon down onto the Earth, and we found that we put the square around the Earth, the blue Earth, there's a square around it, the square symbolizes the Earth, and we put a circle through the center of the moon, and the moon symbolizing the heavens, the heavenly body, and that the square and the circle are made of the same length of string. The squaring of the circle with the moon and the Earth, and then the red line is the Great Pyramid in elevation. I was really struck by it because it seemed a very eerie thing to me at the time. It seemed eerie and strange that this should be the case. And John held that it was done by a creator, by a designer. There's something I couldn't really accept at that stage. I didn't think there was such a thing. I thought it was probably a coincidence or aliens had done it. And then I met Michael Glickman through John, who had been brought in to write a column for the Seriologist. Michael, for those who don't know, is he was an inventor, a professional inventor, Michael. And if you go to Castle Cary Station, which is where there's taken this lovely bench, and you see them all over England, those benches are all designed by Michael Glickman. So whenever you go to Castle Cary, you can think of Michael and his benches. By the way, it's his 70th birthday today. He was going to be here, but he can't make it because he's 70. This is Keith Critchlow, who Michael Glickman then introduced me to, and who I then went to study under. And Keith was one of Buckminster Fuller's students, and was very good at three-dimensional geometry and everything. And we studied all sorts of complicated things in the with its nice picture of Prince Charles, his Visual Islamic and Traditional Arts Department of what's now the Prince's Foundation, was then the Prince of Wales Institute of Architecture. And also teaching there was John. And it was, funny enough, it was, only having met him very briefly here and there, this was the first time I really got to know him, was actually as a formal student of his. And used to often go back to his house after he'd given his lecture, and that would then go on all night. But it really was his talks there on measure, geometry and everything was when I really first came to know him. And he obviously went through these bits of geometry and many others in enormous detail. And very present at that time was John and Keith's essential, bigging up the idea of a creator. There was this creator, again, which I couldn't really accept at that stage. That's really what this talk is about. I was interested in the heavens, though, very much interested in the heavens. And I was looking up, and I was researching geometry in the solar system and coincidences, trying to find other strange things. And here's my result on Mercury and Venus. Mercury and Venus's mean orbits are created by 3 touching circles. And I became very interested in these squiggly patterns that were related to all the harmonograph pictures I'd been drawing as a boy. These are actually how the planets really move around Earth in retrograde orbits. It's a picture by Cassini from the 18th century, showing Jupiter and Saturn's motions around the Earth. And in particular, I became really interested in Venus. Venus is our closest planet. No planet comes closer to us than Venus. And Venus is has a really strange history, a bit like, in the same way that sort of Pan was satanized by the church. Venus was Luciferized. Venus, to the Greeks, was Hespera and Lucifer. And she draws this extraordinary pentagram around the Earth, also became a scary symbol for lots of people. And really, finding out all this stuff about Venus was a revelation for me. Venus draws this beautiful five-fold rosette shape around Earth. And she does it in 8 years. And 8 Earth years are 13 Venus years. So you can see how you get the 5 from the graph from this thing, because the difference between 8 and 13, 2 planets going the same way, is 5. That's why you get a physical 5 resulting from an 8 against a 13. And Venus comes quite close to Earth, and she goes quite far away. And the difference between her closest and her furthest approaches from Earth are defined as one of the golden sections to the power of 4, very accurately, which is defined by 2 pentagrams arranged like that. Venus does all sorts of other very, very strange things, but we're not going to talk about them here. They are eerie. And what's interesting, and why you never see these diagrams in any science book, is because there's no explanation for them at all. Scientists vaguely mutter about things like resonance and things like that, but they don't really understand how it could possibly be the case that that's going on. If you draw a line between, if you put the sun in the center and you draw a line between Venus's position and the Earth's position every day, Venus is going faster than the Earth, sorry, the one in the middle is going fast, so you just draw a line every day. You get that shape over 8 years as well. So it doesn't really matter which point of view, whether you're being heliocentric or geocentric, you still get this wonderful 5. And 5s are really everywhere, aren't they? It is the shape of life, if you think about it. It's nearly the angle of the water molecule. It's the angle, certainly of the humans. Look at us. We're essentially 5-fold things with 5 bits sticking out of our tips, even. And it's a very interesting thing, just the extent to which 5 relates in life. We know about it. We've got our proportions, and this is all relatively well known, the Fibonacci proportions in phi relationships in the lengths of different parts of the body and your teeth. It goes on, it's endless, really. And there are people that sort of, dentists use it. In fact, if you want to buy the best golden section calipers, they're sold by dentists. It's amazing. Really nice ones. And they're used for arranging the size of this teeth here should be the golden section of that one, should be the golden section of that one. For Americans, perfect smiles are often achieved by this sort of serious witch doctory. Your center of gravity as a baby is your center of your body is your navel, with your golden section appearing in your genitals by the time you've grown up. The 2 positions have reversed. That was quite old hat, and I sort of was quite interested in all of that. And this friend of mine, Moff, who's in fact the doctor for the Big Green Gathering, not Big Green, Sunrise Festival. And this is he and I in Africa when we went over to see an eclipse in 2001. And when we were out there, he told me a very interesting thing that I didn't know, which is that your teeth, even your human teeth, that your teeth are essentially, you're not really a pentagram at all, he told me. You're in fact 2 fourfold things like that, embryologically, with 5 sticking out the end. So your 4 things here, your limbs, actually are the same as your teeth, embryologically. So your teeth are actually hands, if it makes sense, and those are your feet sticking up. But you still get your 4. You still have 4. You have 5 teeth in each quarter of your mouth as a child, and those then fall out and replaced by 8 teeth. So you have 13 teeth in each quarter of your mouth. So it's 5, 8, and 13. And getting interested in Fibonacci stuff and reading about it more, I went to work on a book on the golden section for Wooden Books with Professor Scott Olson in Florida, who became a good friend. And Scott, I found absolutely extraordinary, because I thought I'd understood phyllotaxis, but Scott kind of took it to another whole depth and level for me. And essentially, phyllotaxis is the way that plants grow on Earth. 97% of plants on Earth use spiral phyllotaxis. Absolutely enormous. All life on Earth, essentially, is using phyllotaxis. And you can count. I count everything. Poor Susie, my wife. I mean, we had Brussels sprouts at Christmas, and I was like counting the spirals. Brussels sprouts are actually quite a rare example of 5-3 phyllotaxis. And I point this out because most life on Earth is doing 5, 8, and 13. 5, 8, and 13. Everything's doing 5, 8, and 13. Every time you go and look at a cactus, here's a thistle head, you count those spirals, you count the number of spirals are on one way, then you count the number of spirals the other way, you will get 5, 8, or 13. Most life on Earth is doing 5, 8, 13. I had a bombshell of a moment when I picked a bit of pussy willow one day in the spring and lined it up, and there it was. 13 buds in 5 turns, and the 5th one exactly lining up, that 13th bud exactly lining up with the first one. You need to do it. You need to actually experience it. It's not something you can communicate in a talk, I don't think. You need to count it up and just see that nature doesn't do 12. It doesn't do 9. You know, it does 5, 8, and 13. And our nearest planet around us is doing 5, 8, and 13. Our neighbour in the sky, Venus, is doing 5, 8, 13. And everything on Earth, including ourselves, are doing 5, 8, and 13. Wherever you go in nature, you are surrounded by 5, 8, 13. And we are surrounded by 5, 8, 13 in the sky. So this seems to me a very strange and peculiar coincidence. Phyllotaxis is barely understood by biologists. They can describe what's going on, but not how it's achieved or why necessarily. It's very efficient. The 5, 8, 13 in the Venus cycle is not even discussed by astronomers. Around this time, I got to know this man, Robin Heath, who came to stay with me for a whole summer in Wales. He was a really big Sun, Moon, Earth man and had synthesized the whole Sun, Moon, Earth system into the most extraordinarily simple technique involving 18, 19, and the golden section. I'm not going to go into that here. I'm going to return to the eclipse in Africa, and just something that Robin really drew my attention to, that no one had really drawn my attention to before, even though it's the most obvious thing you could possibly think of, really. Robin basically drew my attention to the simple fact that the sun and the moon are the same size in the sky. It's a very, very peculiar, unlikely coincidence. It doesn't happen anywhere else in the universe, and it only happens on the surface of the Earth, extraordinarily. So, you know, you get your annular eclipses, and you get you get your other ones that are longer. So the moon's sort of moving in and out a little bit at the moment. So not all eclipses are focused to a pinprick on the face of the Earth just for us to see. But essentially that's what's going on. They are. And the interesting thing is it's not been going on forever either. It's the time of the dinosaurs that the moon was a little bit further away. So we've got this sun and moon, two huge heavenly bodies, the only two circles in the sky, are exactly the same size for us on Earth. It's a very, 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 very odd and strange coincidence. And it couldn't possibly be any way it could have come about, could it, really? Can you think of how that could have occurred naturally? Certainly when you talk to any sort of scientist and ask them to explain that, they would say, it's a coincidence. Of course it's a coincidence. How could it be anything else other than aliens dragging them in and shaping it in some way? It's got to be a coincidence, hasn't it? Absolutely has to be. So essentially, at this stage in my work, where I'd got to was I'd realized that essentially we've got a perfectly balanced sun and moon, and we've got, those are the two big things in the sky. What's the next biggest thing in the sky? Well, it's going to be Venus, the next brightest, closest thing. And Venus is doing 5, 8, 13. We've got John's work in the middle, the moon and the Earth squaring the circle, which is very odd. And we've got all life on Earth doing 5, 8, 13. And we've got male and female, and basically left and right, and this sort of balanced sun, night and day. We've got this basic dualistic structure on Earth with this sun and the moon above us. Some sort of symbolic integrity seems to be going on. That's where I got to about 3 years ago. And then I met this guy, who's called Dr. Lance Harding, who lives in Utah, and is the friend of Garth Norman for John Major Jenkins. And Lance showed me something very interesting, which I didn't know. And it's essentially the fact that rainbows have angles, fixed angles. I'd never known this before. Very interesting. Rainbows, when you see a rainbow, you're always seeing the same rainbow, the same circle. Basically, you're in a rainbow sort of around 42 degrees, and your outer one's around sort of 50 degrees. So if you point a circle, if you draw the whole rainbow, imagine it's a whole circle, and you see the center of your head in a rainbow is always the middle of the circle, because the shadow of your head it will be the center of the circle. So you put your head down and you open your arms and you look at bow number 1 and bow number 2, you will always draw the same angle. Rainbows are fixed things. And the physics is caused by light bouncing around in the side of a raindrop. Either one bounce for the main bright rainbow or 2 bounces for the outer rainbow. And I wouldn't have ever gone onto this if Lance hadn't showed it to me one day. And I thought it was really neat, and I looked up the angles, and then got distracted by these things, which are called sundogs. Just hands up anyone who hasn't seen a sundog. Oh, keep going. Right, so it's a small percentage, but still significant, about 10%. People haven't seen a sundog. There were two last night, in fact, and they're very beautiful little things. And they're caused by ice crystals high in the atmosphere and can take different forms like that. And they appear generally left and right of the sun, like that. And if you look it up look up the science behind sundogs, they always appear at 22.5 degrees from each side of the sun. Now, you remember that octogram I showed you earlier? 22.5 degrees is the eternal angle of a spike of an octogram. So what that means is that every time you look at two ice halos, or an ice halo, you're seeing the mean orbit of Mercury around the sun. You're looking at the sun, there you're seeing an ice halo, and you're seeing the orbit of Mercury. So that curve there on the ice halo, which slowly evolves, if you see more developed ice halos, like that, or sundogs here, let's look at that one for a moment. We're actually looking at those two little dots, left and right of the sun, are the orbits of Mercury. They really are. If you could actually see, well, Mercury's wobbling in and out between a mean and so on, quite an elliptical orbit, but if you took Mercury's mean orbit and turned it into a glass sphere around the sun, that's exactly where it would be. Exactly. There it is, forming even more, beginning to be a circle. Another one. That is Mercury's orbit. You are seeing Mercury's orbit. Quite extraordinary. And again, a very weird and unlikely coincidence. The chances of that happening are minuscule. And it got me thinking, really, as to what could be causing that. Could there be any relationship between optics and gravitation? Well, none. There is no relationship in physics between something you look at and something happening, or is there? We'll get onto that in a moment. They're very beautiful ice halos, and they're well worth looking out for. You get them on still evenings. It can be summer or winter. Doesn't make any difference. There's a full one round the sun. Every time you see one for the rest of your life, you're looking at Mercury's orbit. And I thought that was fun. And then one day I was standing in my dad's swimming pool. I don't remember why I was standing, but I was probably playing some tag game or something. That's my dad's swimming pool. And I saw something a bit like that, which in fact appeared last night. We had one just before dinner last night with the little hat on. You see that little hat at the top? And that's when I realized that the ice halo thing was more complicated. It wasn't just one ice halo. In fact, like rainbows, there are two. There are two circles around the sun that are drawn. One appears at 22 degrees, one appears at 46 degrees. But again, being a planets guy, I knew that 46 degrees is exactly where Venus's orbit is around the sun. Now, there are only two planets between us and the sun. That means if you look at the sun, there are only two things going around it, okay? And they are basically, Mercury's wobbling around a bit. Venus has really got the most circular orbit of any planet in the solar system. So when you look at a double ice halo, you are looking at the orbits of Mercury and Venus. The chances of that are imperceptibly small. For it to happen once is one thing. For it to happen twice is a repeated effect. And yet there's no possible explanation for it. Very, very strange. There's more double ice halos. If you ever see something like that, which you may only get to see once in your life, you are looking at the orbits of Mercury and Venus. Two circles drawn for you in the sky, two planets there in reality. They both synchronize absolutely perfectly. It's a completely observed effect. It's not a diagram of any kind. It's actually real. You really are seeing what's happening. At this point, I was really stumped. Just before my wedding 2 years ago. And I couldn't sleep. I didn't sleep. I just couldn't sleep. I just thought, this is weird. This is so weird. What could possibly be going on? So this is the weirdest thing I've ever stumbled on. And it sort of seemed to bring in all my work on the planets, and yet it was deeply strange. It was challenging something in me, and I couldn't get to the bottom of it. So I got to this sort of stage. The whole universe is finely tuned for life. You know that? The whole universe, finely optimized for life. And yet around Earth, we've got this, it's finely tuned for what? For wow, really. That's all I got to. It's all you can say is, what's it doing? It's sort of finely tuned for something very strange. There's something very strange going on around our planet. That's where I got to there. Very, very odd. So you're really left with two options, two roads you can go down at this point. you can either do what almost any professional scientist in this room would do right now, which you would say this is a coincidence. There is no physics at all to explain any of this. It's got to just be a coincidence. But if it's not a coincidence, then let's look at the options. And what's interesting is that the responses to the local, what I'm calling the local anthropic principle, i.e. this weird fine-tuning around Earth, and the global anthropic principle, which is the fine-tuning in the universe, actually have the same range of possible answers. And these are represented, in fact, by different professors in different universities at the moment all over the world in terms of the cosmological anthropic. But you can see in a moment how they apply to the local anthropic. One of the main responses to the cosmological anthropic, the fine-tuning in the universe, is that there's simply some science, there's some science we don't know. There's some already existing science within the main body of physics to explain quite a lot of these things, but we haven't quite found it yet, which is a bit like saying there must be a good reason why the universe is finely tuned. It just falls out of the numbers somehow. Maybe that's the case. We don't know. But could it be the case that something like our solar system forming like this with 5813s and 5813s and ice halos matter-bearing rainbows, could that fall out of the numbers? I don't think so. So again, the local anthropic is able to inform your take on the cosmological anthropic. The multiverse. The multiverse is a response to the cosmological anthropic. Why is the universe so finely tuned? Well, it isn't really. Well, it sort of is, but in fact there are millions of universes, and we just happen to live in one where everything works. So he invents all this stuff that sort of doesn't work just to explain why this one does work. That's the point of view currently adopted by our astronomer royal, Martineau, who's also fascinated by this. So that's the multiverse. The biocosm is another response to it. The biocosm says that the reason our universe is so finely tuned is because it's a child, basically, of parents. So that somehow, at the moment of the Big Bang, some other universe got everything right and had a child, which is us. That's why it was all so perfect from the very beginning. Can we apply that to the local anthropic? Can we say that some sort of DNA got through at the moment of the formation of our solar system? Well, maybe, as we shall see. Maybe aliens built the whole thing. It's all just a construction of aliens. This is known as the answer from design. You've still got a designer. You've got designers coming back in. We might as well have put the old man with the beard up there. It's still the same response. Someone built it is the idea. And the someone built it idea, there's a professor at Cambridge at the moment who specialises in this, also goes to the idea that none of it's real anyway. It's a virtual reality. We're all living inside a computer simulation. That's why it all seems so perfect. I find that one quite interesting, but would a computer programmer bother, or would aliens bother with making the ice halos the same as the orbits? Would you do that? It just fries my nut, that one. Maybe there's something far stranger going on. And the take on it, the quantum holographic universe, that's supposed to be those two together, a hologram and quantum and Yoda. The quantum take on it is quite interesting because we tend to technologically always model our cosmology, or we always tend to model our cosmology on our technology. It's an old game, it's been going on for thousands of years. And the quantum computers, which are about to hit us, will essentially be able to solve problems not by solving them, but by trying everything and only spitting out the right answer. That's how quantum computers are going to solve prime calculations, is by having you've got one number times another number equals, we know what the answer's got to be, but we don't know what these two are going to be, and then we can crack all internet security. And you have to imagine every single possible number on that one and every single possible number on that one, so they're all there simultaneously, and you have an output gate that only lets out the right answer. So don't let anything out except the right answer. Bing, the whole thing freezes at the right answer. That's how quantum computers are going to work, and they're being built at the moment. If that's true, and that is our future, our computing future is going to work like that, Roger Penrose has already predicted that quantum computers will display consciousness. And if you think about it for a moment, maybe it's something that tries everything. It tries everything at once, just tries everything at once. We'll always come out with the best answer. Maybe our universe just went, try everything, like bang, came out with this, the finely tuned, beautiful universe. It is possible. Anyway, thinking about all of these things, I contacted Hugh Newman, who's in the audience and is a Lemurian crystal healer. He introduced me to Rupert Sheldrake, and Rupert Sheldrake introduced me to some of his ideas. Rupert Sheldrake spent years interviewing people and about pets and animal stories. It's riveting. He had a column in the Daily Mail, I think, or the Mirror it was, and he said it was the best research tool he'd ever had, just saying, hey, has anyone had interesting experiences with their pets? Can you write in, please? And he focused on dogs that know when their owners are coming home. And all sorts of dogs seem to know how to do this. And can basically sort of, he had these stories of this woman who'd put the tea on, put dinner on when the dog went to the door, because she knew that the husband had left the office. And that could be at any time. He'd leave the office at different times every day. And yet the dog would go to the door when 20 miles away its owner left the office, reliably. Rupert ran loads of experiments. It always seems to be the case. And deep down, weirdly, we know this is the case. Seems right. Doesn't seem to me to be an impossible thing. I've had experiences like that. And we know that there could be a mental connection between man and animal. It's currently fringe science. It's hated by the mainstream. But the idea of mental fields, as Rupert Sheldrake calls it, is also backed up by another bit of his research, which I find very interesting, which is in one of his books, The Sense of Being Stared At. We all know when we're being looked at. We know it, and we can experience it and test it and often feel it ourselves. You walk along a street, you feel a prickly feeling, you look round, and you know when you're being looked at. It's very interesting work. It's not that far out. You know when you're being looked at, and when you look at other people, they can tell that you're looking at them. I sometimes do research this on myself from my office, which overlooks the main square in Glastonbury down the bottom where all the cafes are. And you look out of the window. Maybe it's better if you get 2 or 3 of you and you see someone walking along and you stare at them. And it helps if you sort of think of, you need to add a little flavour to the staring. And if you do that, what fascinates me is that people look round, and they don't just look round like someone's looking at me. They look round and up. They know what vector they're being looked at from. It's fascinating. It's worth experiencing for yourself, because according to physics, none of that should be going on. Mainstream science does not want that to be there, and yet it clearly is an effect. And it's an interesting effect, and it's an effect that's not necessarily that far out. Rupert's idea of mental fields is simply that your mind, when you look out, me looking out into this room, according to modern physics, I'm looking out, and everything that I see, everything out there, as it were, is simply a construct of my brain. It's standard mainstream biology. Rupert takes this much more a Greek idea, really, that that construct, if you like, in my brain is itself a projection then back out, actually has space. It really does have space. My mental field is actually creating connections out there, and we all have mental fields that are overlapping, and that then explains his different effects as a theory. The interesting thing is that it's not a very different point of view, in fact, to where we've got to anyway in mainstream physics. Mainstream physics, we know that everything's behaving much, much, much more strangely than we could possibly have dreamt of 100 years ago. Science became very, very strange about 100 years ago and stayed very strange, and in fact most people aren't sort of even aware of how weird it got, and still live essentially in a Newtonian world where we're all comfortable and everything is boxes and clockwork. And essentially the nub of quantum mechanics is that consciousness affects things. Looking at things does affect them. There isn't such a thing as a passive observer, and also that you can split things very long distances and they stay related and will talk to one another faster than the speed of light. Here's the Solvay conference in 1927. Everybody's there, including the only woman in the story. I'm really sorry, but there she is, Marie Curie. And she and the rest of them at this conference knew that the world was about to change and that they were onto this new world. It's a century later, it's still sort of, we're all using the technology. It exists in all our mobile phones, every technological gadget. And the Copenhagen interpretation, which was put forward by Niels Bohr here, is the mainstream now. Although its implications aren't really taught. Quantum entanglement, widely sort of, they keep repeating the experiment. Quantum entanglement, essentially you get a photon, a high-energy photon, split it into 2 lower-energy photons. They become what's called entangled. You then send them, and they run the experiment in Geneva. You send them in opposite directions, sometimes 3, 4, 7 kilometers apart, and then you measure one end, and whatever you do to one end, the other one does the same. So they are connected. So you've got 2 real phenomena in quantum mechanics. You've got entanglement as one thing, and observation changing things. And if entanglement's correct, then it's very easy to understand why. Entanglement breaks down very quickly. It's one thing to say about entanglement. So 2 entangled particles. Let's say those rays of light coming from that light there, hitting my eyeball, will be entangled. If you can see a little dot in my eye of reflection, that's quite likely to be an entangled particle. I'll be getting a bit of that, and you'll be getting a bit of it. So we're therefore entangled. So you're entangled locally, but you're not actually entangled at a very great distance. The moment you go do anything, entanglements break down when anything disturbs them. But you're therefore much more likely to be entangled with, and really entangled, with someone you spend time with or a family member or things like that, than you are. So the idea of the whole universe being entangled, which is often put forward, doesn't really hold up in physics, but some form of local entanglement does. Best way of putting it. So essentially in quantum mechanics, we've got these three basic scenarios at the moment. What's going on? There's different, what are called interpretations of quantum mechanics. If someone comes up with a theory of quantum mechanics that explains what's happening, or the data that you can use to build mobile phones, then it's known as an interpretation, not a model. There are three big interpretations at the moment. Either we render things by looking at them. That's the Copenhagen interpretation. That's Niels Bohr's one. Essentially, mainstream physics now is that everything is created by, at the moment you look at it. It's very much like one of those computer games when you're running around a computer-generated world. It doesn't draw the whole world. It only draws the bit you're looking at. Well, that's exactly what Niels Bohr says is going on, and that's exactly what is essentially the bottom line of the mainstream at the moment. So the bit you render by looking at, the act of looking forces a collapse of the probability function. Again, you've got an element of consciousness. This is an important thing. Second one, looking at things sends signals into the past which alter the present. That's the double slit and everything. I won't go into this too much because I know it's going to lose everyone. But essentially, that's another full interpretation of quantum mechanics, is that the consciousness operating in the present affects the past, which then recreates the present. If you build a system of quantum mechanics based on that central model, it works. So does the first one, and so does the third one, which was David Bohm's one, which is that the entire universe is not really entangled but connected. It's a holistic structure. And Richard Feynman as well. Feynman diagrams are all about particles splitting and passing through every point in the universe. And David Bohm's theory, which also works down to the last detail, and you can use it to model everything, is essentially that everything is connected. And if everything's connected and it has consciousnesses in it, and if consciousnesses can sending signals back into the past which affect the present, or if by looking at things we're rendering them, or if all three of these things are simultaneously correct, which is probably more likely what's happening, then consciousness has to be part of the universe, doesn't it? It's got to be. Because how can you have something that's integrated with consciousnesses in it without those consciousnesses becoming part of the whole? It's not possible in the quantum world. It's just not possible to have things that are separate like that. So if the act of seeing collapses probability functions and affects things, the act of looking in itself, just looking, and you have a planet full of things with eyes, basically. Everything's looking, everything's seeing, recreating, collapsing probability functions, and all the rest of it. Then might it just be possible that the act of seeing something has caused it to be there, essentially? That there's some relationship between Earth and it having consciousnesses on it that's in some way helped to either create, or as a result of, or in some way entangled with, the story of what I was showing you earlier. It's got to be. It's a chicken and egg problem, essentially. It's the way I see it. And we're getting near the end, so this is the last bit of science for those that are weary of the science. There was one big change in causality and chicken and egg thinking it was the last big bit of science to evolve, really, in the 20th century. And it was chaos theory. Chaos theory was really the equivalent, visual equivalent, if you like, or it's a very simple version of quantum mechanics. Quantum mechanics was the application of ordinary mechanics into the complex plane, which is numbers and square roots of minus numbers, which forms a thing. You apply ordinary mechanics onto that plane, you get all your electron orbitals and everything. If you get your ordinary complex plane and you just run simple multiplications on them, you get fractals. So fractals and quantum mechanics are very similar in a funny way, and chaos theory was born out of that. And chaos theory really models all of the things we think of as being natural and beautiful and curly, and all of these things can be modeled by fractal chaos, what's called chaos mathematics. And chaos theory also predicted one other thing and can model one other thing very well. This is a Lorentz attractor. And that is what we think of as chaotic structures. The ultimate chaotic structure is the weather. So chaos theory came up with this kind of thing that always sums up chaos theory. which is that a butterfly flapping its wings can create a hurricane. And if a butterfly flapping its wings can create a hurricane, then you can't really model the future at all. And that's why you can't model the weather more than 4 days ahead. It is a truly chaotic structure. And it turns out, in fact, that most of what's going on in the universe is chaotic. You can't really model it at all. And in fact, things like solar systems, where everything's just going doob, 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 are really quite rare until you get into the atomic realm and atoms. But really, it's very, very rare. Most of the universe is chaotic. Almost everything is chaotic. And chaos theory really is very interesting, because what you have to imagine is, what if that butterfly was in some way knew what it was doing? I'm going to make a hurricane. So that's something that's really worth thinking about. Could a butterfly knowingly make a hurricane? It's got quite a small brain, hasn't it? But what happens if the entire universe on the left, thought, I'm going to make a nice planet? Could that really be what's going on? Could it really be that the moment of the Big Bang, back to that quantum thing again, in the same way you've got the quantum universe going, I'm going to try everything, come up with the best thing, that in some way some signal gets through, because our solar system gets to be how it is, with the sun and the moon being where they are, with us on the planet looking at it all thinking, this is weird, isn't this extraordinary? Could that all be a moment in space-time that was somehow dreamt of anyway by a universe that was sort of able to sort of create it through the moment of the sun? I mean, it's a bit like throwing a ball. Martin Rees always likens the anthropic principle, the fine-tuning in the universe. He always likens it to throwing a ball up a 44-level spiral staircase, and you've got to throw a ball and it's got to stop exactly at the level of the top banister. That's how finely tuned the universe is for life. And the answer to that is, yeah, you could do it if you're a really good athlete, if you really knew how to throw balls well. And it's the same problem. How are you going to end up with a planet with life forms on it that are going to go ping exactly at the same time that you've got a sun and moon, and with the same size and all this stuff doing that? How could you actually pull that off? It's either a coincidence or it's not. If it's not a coincidence, then this is the only way you could do it. It really is. I can't think of another one, other than aliens dragging it all, really creative, beautifully, really lovely artist aliens. How would you get the solar system to be this lovely and beautiful and synchronized, except by something like that? It's a very odd thought. How would you get all of this to be simultaneously working? I can't think of another way, and if you can think of another way, please email me. How can you pull it off? It's very, very strange. I think Earth is flowering at the moment. I think it's organic. I think the whole universe is probably conscious, and that we as a planet are flowering. We're flowering as a form of consciousness, and we are flowering in the eye, if you want, of a perfect sort of coincidental, perfectly well-organized, evolving, but beautifully arranged at the moment, kind of flower. We're like in the middle of this thing. We're in the middle of a lotus. It won't always be here, but it's here now. It's going to be around for quite a long time, beautifully tuned like this. And this is a testable theory, because it basically suggests that there's a relationship between minds on a planet and what's going on around them. And it's testable in this case that we could basically, if we find other planets with bug-eyed monsters on like us, we would therefore expect that probability to have been warped around those planets too. So this theory basically predicts that around other planets of intelligent, conscious life, you will also see very, very eerily beautiful coincidental patterns. You will find them there too, and you don't find them anywhere else, probably. So it's an interesting theory. It could be going on anywhere. So we're nearly at the end, and there's sort of just one last little end bit to this story. And Charlie Tayard, who's here today as well, who'd been keeping up with all of this work, said to me that, hey John, well, what about rainbows? You haven't done rainbows. There's all these ice halos. I sort of thought, oh God, it all started with rainbows, didn't it? With Lance and everything. Oh, I better look at rainbows. So I went back to some rainbows, looked at rainbows, and saw a few, and was sort of thinking about them. And I got the angles for rainbows, and fed them into my computer program and database of angles. I've got a huge database of angles and geometries, and I can just take anything and plug it in, and it'll spit out what it hooks up to. And I didn't know what would come out when I ran this one. But one of the first things it found, which was really interesting for me, was that Of course, when you look at an ice halo, you're looking towards the sun, aren't you? There's the sun, and there's ice halo number 1, there's ice halo number 2. We can see Mercury and Venus. Very, very odd, their orbits. There they are, we've been going round. And when we look at a rainbow, we turn around from the sun, and we see our shadow. There's my shadow here. That's the center of the rainbow, and the rainbow does that. In fact, if we look at the sun, we've got Mercury and Venus, but if we turn around, who's behind us? Well, the nearest planet on that side is Mars, isn't it? But you can't see Mars's orbit because it's going, can you imagine? You can't see it. We can see Mercury and Venus, can't we, as circles, actually see their orbits. But Mars is outside us, so you can never see it as a circle because it's bigger than anything you can get at. It's going round you. But what's strange is if you do take a step back and you go and imagine you're on Mars, I'm on Mars now, let's imagine I'm on Mars, then when you look at a rainbow, you're seeing how big Earth's orbit is from Mars. So that's exactly how big Earth's orbit from Mars is. Again, it's the same principle repeated. And it's done it as well as it can. It's tried really hard for us to make something cool. But of course, that's just the bright rainbow, isn't it? What about the double rainbow? The double rainbow is the kind of arc, sort of hippie symbol, isn't it, of all things hippie. And here's a bunch of hippies, And of course, it suddenly had to be this way. When I fed the double rainbow into my program, what it came out with was that the thing that best fitted the double rainbow was the squaring of the circle. John Michel's main diagram. Essentially, every time you see a double rainbow, you are looking at the squaring of the circle. You're looking at John's 2 circles. Every double rainbow does that. What's fascinating about that, again, is that it has symbolic integrity. It's been designed, it's not been designed, it's been, when I say it has symbolic integrity, I mean it does what it says on the tin. The double rainbow is the ultimate symbol of the bridge between heaven and earth. In fact, if you do research online, the double rainbow is the bridge between heaven and earth in almost all cultures. And it's always known as that. It's the covenant, whatever, in the Bible, and the Hopis, it's often the bridge. Bridge is heaven and earth. You never really see the whole circle. You're always seeing this kind of half of it. And we know that the squared circle bridges heaven and earth. It is the symbol of the unification of the heavens and earth, with the circle and the square, the moon and the earth, and the double rainbow doing it. I mean, it's so far out, this stuff, that you could be locked up for being a flower power fanatic. We got flowers, we got halos, we got rainbows. It's absolutely bonkers. It really is very, 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 very strange material. Sun and moon the same size. I mean, look at Robin in that picture. It's dangerous material. That's the best one I've done of it so far, because I thought John would really like that one. He never got to see this, because it only got cracked about 4 months after he died. So I always felt that somehow he was sort of floating around, sort of feeding it through. It was very strange. That's what happens if you look at all of the geometry of the whole thing, with the ice halos on the right and rainbows on the left. And it does all sorts of interesting things as well. So, yeah, I suppose, really, this talk really ends again with what is the universe. I hope you've got a little bit further today in your understanding of what it is. And I've managed to communicate something of my own journey as to what I think the universe is. We don't really know what it is. I certainly, in my own relationship and talkings with John over the years, and I used to disagree with him a lot, because I did not think there was a designer or a big brain or any of it. I thought it was all... I'm now at the point where I can't see how it's possible that there isn't a big cheese. There's got to be. There has to be a very big brain. And it's probably operating through these moments of birth, like the Big Bang, like the formation of our solar system. That's the moment you throw the ball, isn't it? That's the moment you've got to get it right. That's the moment that butterfly's got to flap its wings properly. Exactly. And that's probably been guided somehow by the big brain. As to whether there are aliens or not, and all the rest of it, back to the Fermi paradox, in a funny way, we've kind of left them behind in this talk, really. And we don't really know what we're going to turn into in the quantum future that we're about to hit, or if this sort of stuff ends up being mainstream, and this is where the quantum thing is leading, because it is the sort of thing. We have no idea where we're going to end up, either as a species or technologically. And maybe the reason that there aren't any aliens landing on the White House lawn is simply that we don't end up flying around in great big clunky metal spaceships. So who knows what the universe is? Thank you.